Let's go to page 659. This is lesson 10.2. And this lesson is to find arc measures. Okay. A central angle of a circle is an angle whose vertex is the center of the circle. So this is an example of central angle right over here. So this is a central angle right over here. Okay? When the vertex is the center of the circle. It says in the diagram, angle ACB is a central angle of circle C. So again, the angle ACB, this angle right over here, that's the central angle. If the measure of angle ACB is less than 180, then the point and the points on the circle C that lies on the interior of the angle ACB is a minor arc with endpoints A and B. Okay, so this is an example of minor arc. Okay. The points on circle C that does not lie on the minor arcs AB forms a major arc. So this is a minor arc, this is a major arc. So basically the big one is a major arc, small one is the minor arc. Okay. Okay, a semicircle is an arc with endpoints, there are endpoints of a diameter. So a semicircle is if you cut this in half like that, okay? So this example of semicircle means half of the circle. So this would be a semicircle. Okay, so next let's go naming arcs. Minor arcs are named by their endpoints. The minor arcs associated with angle ACB is named AB. So this is arc AB. So like over here, so this is your arc AB. Okay. The major arcs and semicircles are named by the endpoints and a point on the arc. Okay, the major arc associated with angle ACB can be named A on the arc, so arc ADB. Okay. So in other words, minor arc use 2 letters. Major arc use 3 letters. Okay. So again, 2 letters for minor arcs, 3 letters for major arcs. So when you're going to name major arcs, you have to put additional point, and then you get the 3 letters. Okay, next one, measuring arcs. The measure of a minor arc is a measure of a central angle. So if this angle is 50, then the measure of arc is 50. Okay. The measure of the entire circle is 360. So the measure of a major arc is a difference between 360 and the measure of the related minor arcs. Okay, the measure of the semicircle is 180. Okay, so again, to find these, okay, remember one circle is 360. So 360 minus 50 will give you 310. So arc ADB, so measure of arc ADB is 310. Okay, so you can measure arc, you just minus the minor arcs and you get that. Okay, now let's go to example 1. It says find measure of arcs. Find the measure of each arc of circle P where the segment RT is a diameter. So RT is a diameter. Okay, so first you're looking for RS. Okay, so RS is giving, right? It's 110, it's giving. Then arc, RTS. Okay, so RTS, what 360 minus 110 will give you 250. Right? So again, 360, that's the whole entire circle. Your minus 110, that will give you this part over here. So 360 minus 110 will give you RTS of 250. Next, you're looking for the arc RST. So RST. Well, since this is a diameter, this is a semicircle, and semicircle is half of the circle, so it'll be 180. Okay. Okay, let's go to the next part. So on page 660, adjacent arcs. 2 arcs of the same circle are adjacent if they have a common endpoint. You can add the measure of 2 adjacent arcs. So example like over here. So AB and BC are adjacent because they are next to each other. Okay, so they're adjacent. And you can add this together. So measure of arc ABC is equal to AB plus BC. So again, AB plus BC will give you ABC. Okay. So again, so this is postulate 23, arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Okay, again, so it's a bit of common sense, right? When you have two arcs next to each other, you can just add them together to find the sum. Okay, now let's go to example 2. Survey. It says, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in a circle graph, or another word for this is called a pie graph. So circle graph or pie graph. Find the indicated arc measure. Okay, so here's the example here, right? Okay, so measure of arc AC. Well, first, okay, so notice the degrees are given. So to find arc AC, just add these two together. So it would be 108 plus 29 will give you 137. So again, over here, right? So you just add this together give you 137. Just add this together. Okay, measure of arc ACD. So ACD. So from here to here, remember, it's measure arc. So you have to, there's a reason for putting the letter over here, so that way you know what direction to go. Okay? So arc ACD means you have to go from A to C to D. So in this case, you add these three numbers together. So you add 29. So you have so 29 plus 108 plus 83. Okay? Or in this case, since we did this in part A, so they just kind of use that. Okay, so that's fine. But anyway, you add these three together, you get 220. Okay. So let's go to part C. So you're looking for ADC. So ADC. So you have to follow the letter right from A to D to C. So you have to go this way now. Then you have to add these three numbers together. Okay. Another way to do that is you use 360 minus that. Okay. So again, two ways to do this. You can add 79 plus 61 plus 83, or you can use 360 minus 29 minus 108. Now, since we already did this from part A is 137, but we already know that this is 137, so you can just use 360 minus 137. So 360 minus 137 give you the same result. Okay, again, you can do it different way. You can use 360 minus that, or you can just add these three numbers together to get the answer. You get the same answer. Okay, let's go to part D, measure of EBD. So EBD. So again, you have to follow that. So E to B to D. That means you're going to find the arc for all this whole thing over here. Again, you can add this number together. You can use 79 plus 29 plus 108 plus 83. Or you can use 360 minus 61. So I think it's faster if you just use 360 minus 61. Okay, so 360 minus 61, you get 299. Again, you can verify this by adding this together. So 79 plus 29 plus 108 plus 83. You should get the same answer. Okay, now let's go to page 661. Okay, let's go and do example 3. It's identify congruent arcs. Tell whether the red arcs are congruent. Explain why or why not. Okay, well, part A, they are congruent because remember, the central angle is equal to the arc, right? So if this is 80, the CD will equal to 80. Measure of CD will equal to 80. Since they have the same central angle, therefore the arc will be congruent. Okay, so you can solution arc CD is congruent to arc EF because they are in the same circle, and by the way, they have to have in the same circle or congruent circles. Okay, and measure of arc CD equal to measure arc EF. Okay, again measure, see over here. Okay, B. Are they congruent? The answer is no, because they are not on the same circle, and also they are not on congruent circles. Okay, so they are not congruent because they are arcs of the circle. They are not congruent. Okay, next one. Okay, so notice the red hash mark. That means they have the same radius. So if they have same radius, means the circles are congruent. Therefore, if they're congruent and if they have same central angles, that means the arcs are congruent. Okay, so you can see the VX, the arc VX and arc YZ are congruent because their measurements are congruent.